Hey guys, today we're going to do an exercise where we investigate the effect of force on objects. So as we know, when we push on something, we can make it move. And if we push harder, we make it move more. But in this one, we're going to try to fine tune that a little bit and be a little more precise. So we're going to be using one of the physics classrooms simulations like we have done before, and be collecting some data and then trying to find some patterns in that data. So let me show you the simulator first. You already have the link, so we'll get to that. So we hit start on this and it shows up. So what we can do on this is we can change the mass of the object. We can go from 0 to 5 on it. And for this one, we're going to leave the mass set on 2 kilograms. 2 kilograms. That's on the worksheet. You'll see that in a moment. And then we can also vary the force from 10 all the way up to 100 newtons. We are going to, actually, we do change the mass from time to time. Most of the time it's going to be 2 kilograms. Anyway, we can also adjust the friction on this, which is how hard it is to push the thing across the surface. But to keep it simple, today we're going to use 0 friction. We'll always keep the surface friction set on 0.00. Now, when we push this thing and say push it, then it starts to accelerate. You can see the little hand, which is pushing it to the right. And it creates a velocity versus time graph, which describes the motion of the block as the force acts on it. Okay, so what does this graph mean? So on the x-axis here, this is how much time passes, and then this is how fast it's going. So this nice sloped line here means that the thing is going faster and faster and faster as time goes by. And once we do a run, we can hit reset, we can put in different forces, push it again, and we get a different curve. Okay, now what are we going to do with this information? I'll show you on the document camera here. Here it is. So this is what the worksheet looks like that I'm giving to you, that you already have. And this is the table you're filling in. You're going to do 10 different trials on this to collect data. And then on the second page, you'll collect information. You'll look for patterns among the information that you collected. We'll get to that in just a moment. So how do we record this data and what do we record? We'll start with the first one here. 10 newtons, 2 kilograms. The first column is net force. Now, this term net force means the total forces that are acting, because it turns out that forces add up with each other and the direction matters. So back to the sim here. When we push on this, the only push is to the right. But imagine if somebody was pushing on the right side of this block, pushing it back toward you. Well, then it would turn into a shoving match, and whoever has the stronger force is going to win, and that's the direction it's going to go. But today, again, to keep it simple, we have only a single force, just the one force pushing it to the right. So that for our worksheet here, the net force is going to be the force that we set in. So that's going to be 10 newtons in this particular case. Now we go back to our sim. And when we say, so we have it set for 2 kilograms, 10 newtons, no friction. We say push it, and we get our velocity versus time graph. Great. Now the second thing on the worksheet, it asks you for velocity time information. And we're collecting information that we need to calculate the acceleration of the block in the sim that we did. So the information we need, we get from the simulation itself, from pushing a button on the graph. So for example, we can push this one and it tells us 3 seconds, 15 meters per second. So this tells us that 3 seconds into the simulation, it was moving at 15 meters per second. And we're going to write that in our worksheet. So 3.0 seconds, 15 meters per second. And it turns out this is enough information for us to figure out what the acceleration is. Because as you may recall from last time, acceleration is equal to a change in velocity in some change in time. And in this case, we have the change in velocity is 15 meters per second because we began from a standstill. So it was not moving and then it was. So our change in velocity is 15 meters per second. And that change happened in 3 seconds. So we're going to divide this by 3 seconds. A change in velocity, 15 meters per second, divided by a change in time, 3 seconds. 15 divided by 3 comes out to be 5 meters per second squared, because that's the units of acceleration. And if you want to keep it in the form that they have on the form here, which is meters per second, in other words, the speed changed by 5 meters per second each second. It happened for 3 seconds, so the total change was 15 meters per second. If you want to keep it in those units, that's fine. But bottom line here, 5 meters per second squared, that is our change in velocity. Now, you might be wondering what might have happened if I had used a different dot, like what about this one, like 2? Well, then we're going to get different numbers. But since the acceleration is always the same, we should get the same answer. We should get 5 meters per second squared for this particular setup. Now, when you do this worksheet, I want you to use a point other than the 3-second point. That's the one I use to show you. I want you to use the 4 or the 5 or the 1 or something like that. And I think you'll see that the acceleration comes out to be the same. It should. Okay, so once you have the information for the first one, then you reset the sim, and then you put in the information for the second one, which is still 2 kilograms and now 20 newtons. And we push the button. We choose a point, and we write down the information. 3 seconds, 30 meters per second. So our net force was 20 newtons. In 3 seconds, we went 30 meters per second. And now our delta V over delta T is 30 meters per second times 1 over 3 seconds, and we get 10 meters per second squared is the acceleration for the second trial. Again, when you do this, I want you to use something other than 3 seconds, but you should get the same answer. Okay, so I want you to be able to practice this equation knowing the answer so that you can make the numbers you get spit out that answer. Then you can be sure you're doing it right. All right, so you're going to do that for all 10 trials here. There's different masses and different forces to give you a variety of data points. And then you flip over to the other side here, and we get to the analysis section. And this, like the first one, what does doubling of the net force have on the acceleration of the object? So you're going to keep the mass the same, and you want to find 2 of your data points from the front and see, okay, what happens when we double the force, like go from 10 to 20 without changing the mass? What is the result? And they want you to be quantitative, meaning actually use numbers. Don't just say it gets bigger or smaller, say by how much. Like if we double the force, does that make 4 times the acceleration or half the acceleration? What does it do? So use numbers. And then finally, identify which 2 trials you used to prove that to yourself. So trial number 1 and trial number 2. You doubled the force, kept the mass the same, you looked at the result. So you got to tell me which data points you're using to draw your conclusion. 5 questions like that. And then finally, they want you to find a larger pattern, generalities about how acceleration varies with force and with mass. I want you to find general patterns in that. Okay, so make a claim and support it with some evidence from the trials about what happens when you increase force on the same mass, and what happens when you increase mass using the same force. What happens to acceleration? Okay, so we're hoping that with this exercise here, you can discover something about forces and acceleration by yourselves without having to just read it out of a book. Then we'll get into more detail on it next time. Okay, I hope you have fun with this one. Good luck with it, and we will see you next time.